All right, so we're going to be factoring by grouping. And the reason we need to do factoring by grouping is because I have 4 terms. Normally we factor with 3, but here I have 4 terms. So what that means is I'm going to be no longer using the AC method. I'm going to be grouping. And what that means is I'm going to group these 2 terms on the left. And I'm going to take these 2 terms on the right. And I'm going to kind of group them separately. And then I'm going to look for a GCF, a greatest common factor, something that these 2 terms have in common. Well, what do they have in common? If you're looking at 3 and 3, well, they're both divisible by 3. So they have a 3 in common, and they also have some x's in common. If you look at x cubed, this side here, they have x cubed on this side, and we have x squared over here on this side. Well, how much of those x's do they have in common? Well, there's one of them has x to the 3rd power. The other one has x squared. So we're looking at they both have 2 x's. Now this one has 3, this one has 2, but they both of these have at least 2 x's. So I could say that they have x squared in common. All right. Now when I factor out that GCF, I got 3x squared. That's going to be part of my answer. The GCF over here is what I'm looking for. That's going to be part of my answer. So 3x squared is part of my answer. Then I'm going to go to the other side, and I'm going to do the exact same thing that I just did. So I'll go over here and I'll say, well, what do these 2 things have in common? Well, 2 goes into both of those numbers, so they have a 2 in common. And they don't have a variable. This one has an x, the other one doesn't have an x. So the only thing they have in common over there is 2. So my GCF over here equals 2. And that's the other part of my answer. All right, so I've got 3x squared plus 2. That's part of my answer. And all that is the GCF on the left. And I got that GCF over here on the right. That's where those 2 numbers came from. And what I'm going to do next is simply reduce the fractions that I just created. Okay, so I'm going to reduce the fractions on the left and the fractions on the right. So if you look at this here where I factored out a GCF, if I look at that separately as its own fraction, you'll notice that if I reduce this, the 3's pretty much just cancel out. And that leaves me with x cubed over x squared. Now, x cubed over x squared, if I'm going to reduce that, it's just going to leave me with x. Because if you remember, if I have x cubed, that's technically x times x times x. If that's over x squared, the reason that gives me x is because there's 3 x's on the top, there's 2 on the bottom. The 2 of those are going to cancel out because I've got 2 in the top, 2 in the bottom, and it's just going to leave me with this 1 x left over. Okay, so I just reduced that fraction. Now over here, I've got negative 3x squared divided by 3x squared. When you divide a number by itself, you're going to get 1 because 3 divided by 3, it gives me 1. But this is a negative 3. Now these x squares cancel each other out, but a negative 3x squared divided by 3x squared is going to give me a negative 1. Okay, because I'm dividing a negative by a positive. Different signs when I divide always give me a negative. And the same thing happens over here. When I reduce these fractions, the 2's cancel, just leaving me with an x. And over here, negative 2 divided by 2 gives me negative 1. All right, it's important that that sign is there, this negative 2, just like on the other side where I had that negative 3, it gives me a negative 1. And you'll notice that these are a matching set right here. Okay, if you get a matching set, when you reduce those 2 fractions, you can go ahead and just get rid of this one. I don't need this second one. I only need that factor 1 time, so I can cancel the other one out. And that would be what my final answer looks like. Now there's something I want to look out for though when I am grouping these 2 things together. Now when I group this left side and I group the right side, I want to look at this sign right here that's in front of that second term. Now that's important because it's going to change my answer if I leave it out. When I take this 2 in, I want to include the sign with it. On the other problem we did, the number over here was positive and it didn't really affect my answer. But if there's a negative right there, it's important that I take this negative and I include it with the 2 in. I don't want to just get over here and start grouping things and do this. and leave that negative in the middle. That's going to give me a different answer. So what I want to do is I want to group that negative with the 2, and then I'll do everything exactly like I was, with one exception. And I'll show you what that is. So now when I factor out a GCF, and I want to focus on this side first, because I want to show you why I have to include that negative. If the negative is in the front, I'm going to look at these just like I normally would and say, okay, well, they both have a 2 in common. Just like on the other side, there's no variable. But this negative, if it's in the front, it's going to change what I factor out. Here I'm factoring out a negative 2. Okay, and that number in the front, the leading coefficient, will determine that. That 2 in the front was negative. That means I factor out a negative 2. Okay, so that was the GCF over there. Now I'll do this one over here. It's positive in the front. Nothing's going to change. I'm just going to factor out the 3 that 3 and 6 both have in common. That's their GCF. And just like in the other example, these have at least 2 ends in common. One has 3 ends, the other one has 2. They at least have 2 in common. So my GCF over here, 3n squared, that's going to be part of my answer. This negative 2 that I factored out is going to be another part of my answer, and I'll just group those together like we did when we were factoring. And now I can go back and reduce the fractions that I got. If you look at our fractions, I've got 3n cubed over n squared. The 3's are going to cancel. And n cubed divided by n squared just gives me n. Now watch your signs. This is a negative 6n squared over 3n squared. Okay, negative 6 divided by 3 gives me negative 2, and the n squares just cancel each other out. Okay, now I'm going to look at the right hand side, and I'm going to do the same thing. I'm going to reduce these fractions. Well, negative 2n divided by negative 2, two negatives give me a positive, so I'm just left with n. And then positive 4 divided by negative, different signs, always give me a negative when I'm dividing. So that is going to be my answer, but remember, if the two factors n minus 2 and the other one n minus 2 over here on the right, if they match, if they're a matching set, I can mark one out. I don't need it. My answer will just be these two factors here. Now if it had been different, if I'd gotten say n plus 3, I would include it in my answer. But if they're a matching set, just mark this one out and you're done with it. All right, now that is factoring by grouping.